Okay, today we're going to derive arc cosecant x, and the first thing that we're going to do is we're going to let it equal y, because that doesn't go without speaking. You have to write it down in a problem like this. So let cosecant x, arc cosecant x equal y, and then we can look at the inverse relationship of arc cosecant x equals y, which states that it's the same thing as cosecant y equals x. Well, that's great news because this we can differentiate. This we know how to differentiate already. So we're going to use that with implicit differentiation. We are going to solve for the slope of the tangent line, which is going to be dy by dx. So we're going to differentiate both sides. That's going to be our first step, is to differentiate both sides. So that's going to be d by dx of cosecant y equals d by dx of x. Now note that it's not d over dx. It's not a fraction. We aren't dividing d by dx. It's the change in rate in x over the change in rate in x. Well, in this particular case, that's 1. But on this side, it's going to actually require a chain rule. So we're going to do that work. We're going to do that work over here. Well, the first thing that we want to write down is our outer and our inner functions. And then we'll know what we're composing with what, because the chain rule is required because this is a composite function. I'm going to use f and g notation. This is going to be f composed with g of x. Well, in this case, that is going to be cosecant x composed with y. Our outer function is therefore cosecant x, and the derivative of that is negative cotangent x cosecant x. And our inner function, g of x, is y. And the derivative of y is dy by dx. This is what we're solving for, this right here, so it's very important. Okay, so now we have everything we need to apply the chain rule to the left side of our equation. So let's do it. Number 2, the chain rule. We are going to make this the derivative of cosecant x of y instead of x, and then multiply it by dy by dx. So this is going to become negative cotangent y times cosecant y times dy by dx equals 1. Well, we want to get this on its own. We want to isolate this. So we're just going to divide by negative cotangent y cosecant y. And we're going to end up with dy by dx is 1 over negative cotangent y cosecant y. Well, now what do we do? Well, the first thing we can do is just exchange cosecant y for x, because up here we know that just equals x. So that's very quickly going to become 1 over negative cotangent y times x. Well, now we just have to get rid of our negative cotangent y. Well, what do? What we do is we look at this up here. And we think, okay, cosecant y equals x. Well, anything is itself over 1. And that might remind us that cosecant is the reciprocal of sine. And sine is opposite over hypotenuse. Well, that means that cosecant is hypotenuse over opposite. And when we look at this, we think, well, we have a triangle here, don't we, with one missing length. Well, we can solve for one missing length. So let's solve for the missing length. This is going to be our y, and this is going to be 90 degrees. Well, we know that the hypotenuse is x. We know that the opposite is 1. So this is our missing angle. Well, by the Pythagorean theorem, and we're not going to do that math here because it's much lower level math. So if you need to refresh that, I definitely would, because it's important for this, but you're probably not very interested in that if you're looking at the derivative of our cosecant y. So it's actually going to be x squared minus 1, because it's really x squared minus 1 squared, and 1 squared is just 1. So that is the length that we're missing right here, right? Well, this length is going to help us enormously, because cotangent is adjacent over opposite. Well, we have a triangle with 3 lengths here. We know them all. So that actually, adjacent over opposite, is actually the square root of x squared minus 1 over 1, which is just the square root of x squared. So we have our solution already when we look at this, because dy dx of y, so dy by dx equals 1 over negative square root of x squared minus 1 times x. Well, that doesn't look very good. We're going to rewrite it. It's going to become negative 1 over x times the square root of x squared minus 1. And there we have our derivative.